Okay, welcome to this lesson, and this is the third lecture of algebra course. Okay, so we are still in the algebra basics, and this is the third lesson. Okay, and after finishing algebra basics, we're gonna move on to advanced topics. Okay, so today's topic is exponents, or indices. Okay, exponents or indices, you can call either of them. Okay, so what is an exponent? Okay, so let's start with the number first. Let me just give you the meaning of this in terms of number, then we're going to move on to variables. Okay, so when we have like 2 to the power 5, this is 32. And how come this is 32? It means that 2 here, okay, if you're just a beginner, then you actually need to be introduced with this. Okay, it means that 2 is multiplied to itself 5 times. Okay, 2 is multiplied to itself 5 times. Okay, so 2, 2, 4, and 5 times. If you multiply this, you're going to get 32. 2 to the 4, 4 to the 8, 8 to the 16, and 16 to the 32. Okay, and this is what does exponent mean? If you have 3 to the 5th, it's called 3 to the 5th, or 3 to the power of 5. Okay, it means that 3 is multiplied to itself 5 times. Okay, and this is 3 to the 5th means. Okay, and here this term, this number is known as the base. This is known as the base, and here this number is known as the exponent. Or this is T here, exponent, or index. Exponent or index. Okay, so this is what it is. This is the base, this is the index or exponent. So if you talk about this in algebraic terms, okay, in terms of variables, if you write a to the power n, a to the power n, so this means, okay, this is the exponent here, this is the exponent here. Okay, you can also call this index, and this is the base. In this term, this is the base, and this exactly means that a is multiplied to itself n times. Okay, so this is n times. Okay, so this is what it means, n times. A is multiplied to itself n times. This is a to the power of n means, and this whole expression, this whole term, no, sorry, it's not expression, this whole term is known as the power. Okay, so this whole is power of what? Power of a. Okay, so a to the n is power of a, okay, or power. This whole is known as the power. Okay, so these are the basic terms. Okay, so when you have 2 and 2 to the 5th is 32, then you can also call it 2 to the 5th power is 32. It means this is the power, and which power? 5th power, when it is raised to the exponent of 5. Okay, we raised to the power of 5, raised to the power of 5. When you have the exponent 5 here, this whole is 2 raised to the power of 5. This whole is the power, 2 raised to the power of 5. Okay, so when you say 2 raised to the power of 5, it means this whole. Okay, so how do you read this? A to the power n, it means we read this as a to the power of n. Okay, a to the power of n, and this whole is a to the power of n, and this only is exponent. So this whole is power, this is exponent, and this is base. So I hope the basic terminologies are clear now. So the terminologies that we talked about are exponent, also known as index. Okay, second is the term called base. Third is the term called exponent, base, and power. Okay, power. So these are the terms that we have talked about, and I hope you have got this well. Okay, so let's now move on to some rules of exponents. Okay, some rules of exponents. So what are the rules? It means, okay, so let you know here. First is the product rule. Product rule. So what does the product rule means? It means, see here, product rule means multiplying two powers. Okay, so a to the power of m, this is the power, times a to the power n, let's say. And if you multiply these two, what you're going to get is you're going to get a to the power of m plus n. Okay, so when you have this a to the power m and a to the power n, it becomes a to the power m plus n. Okay, so you can have other variables instead of these as well. Okay, so this is the rule, and you have to actually keep this in your mind. And if you are curious where this rule comes from and how this is, okay, then the rule comes from this, that when you have the power of any number, let's say 2 to the power 5th times 2 to the power 6th, then what you do is you add those up. It's 2 to the power 11th. How come you add those up? That's the thing that we're going to find out. And let's go to the root meaning of these. It means 2 is 5 times. It means 2. Okay, let's give it, small number, so you don't have to add too much 2's. Let this be 2. Okay. Now 3 2's there and 2 2's there. Okay, so I changed the exponent, so you do not have to add too many 2's. Okay, so how many 2's you got? You got 3 2 5 2's, 2 to the power 5th. Okay, so this is where this rule comes from. When you, this is based on the characteristics of real numbers. So algebra is actually based on the characteristics of real numbers. Okay, so when you multiply the powers of real numbers, what you get is actually the power, the exponents, not power, the exponents added here. You get the exponents added here, and this is where the rule comes from. Okay, but obviously you're not gonna do these steps to remind yourself this rule. Okay, so keep this in your mind. Okay, keep the rule in your mind, and you have also got where does the rule come from. Okay, second is the quotient rule. Okay, quotient rule. Okay, so what is the quotient rule of exponent state? Okay, so when you have, let's say, a to the power m divided by a to the power n, something like this, so the quotient rule of exponent states the opposite of the product rule. In product rule, we have the exponents added, and this we're going to have the exponents subtracted. Okay, but notice that we're going to have the same kind of base in both the terms. In both the terms, we have the same base here. Base is a. Okay, then we are only allowed to do this. Okay, so that was the quotient rule. Basically, comes from the same kind of thing. Let's say let's get another kind of number this time, to the power 5th. Okay, let's give you bigger number this time, and to the power 3rd. When you have this kind of thing, what you do is this is going to be 4 to the power this. It means squared. And if you don't know how come this is, or want to get the proof of this, then I'll show you here. So this is too simple. It means that 4 is multiplied to itself 5 times, pretty simple, divided by 4 multiplied to itself 3 times. So these 4 and these 4 cancel out, and we're left with 2 squared, or 16, in other words 16. So that was the exponent quotient rule. And I hope this is clear. Let's move on to the next rule. Don't make a noise. Okay. So I should have just left it written. Okay. I should have left this one written. Next is the power rule of exponents. Okay. Power rule. Power rule of exponents. So what does that mean here is power. For example, this is a power here. Let's say a to the power m. And if you take the power of this as well to nth power. And what does it state is that when you have this kind of thing, you can multiply the exponents here. So this is going to be a to the power m times n. Okay, so you can multiply the exponents, and this becomes this. Okay, and again, if you want to get the proof of this rule, you can try it. You can also try this on your own before watching the video. But anyways, I'm going to show you. And if you want to comprehend this rule, we can again try this with real numbers. Let's take 5 in this example now. Okay, in this example. When you have 5 squared and its power is third, do the same kind of thing, do experiment with this. You can write this as 3 times this power multiplied to itself 3 times. And now you're going to reach, what you're going to do is you're going to add up all of them, which is going to get you 6. It means that these two are multiplied. The exponents are multiplied. So you can multiply the exponents and you get this answer. Okay. So this is what it means, and this is where the power rule of exponents come from. The power rule of exponents. Okay. Let's now move on to another rule. And what is that? Zero exponent rule of exponents. Okay. Zero exponent rule. Let's write it here. Zero exponent rule. This is the fourth one. Zero exponent rule of exponents. So what does the zero exponent rule of exponents state? Okay. So for example, let's say you have a number a to the power 0. Okay. Let me just give you in terms of variable first, the formula. When you have a to the power 0, it is equal to 1. How come? Let me just elaborate here. Let's experiment this in a number. Let's say 2 to the power 8th, okay, divided by 2 to the power 8th. Okay, let's write like this. You want to find out 2 to the power 0. Okay, you want to find out 2 to the power 0. Now, you can write this term as 2 to the power 8th divided by 2 to the power 8th. How come? Because we are familiar that when you have divisions and they are the same base, then you can subtract the exponents and it will lead you to the same thing. Okay, so this is, and after this, instead of solving this with exponent rule, what we're going to do this is we're going to cancel them out as we do in normal divisions, in arithmetic. Okay, we're going to do just like that. And if you do this, you're going to get the answer 1. It means 2 to the power 0 is 1. And if you experiment with any real number, you're going to get the same answer, that it is 1. Okay? It means 8 to the power 0 in formula is 1. Meaning anything to the power of 0, anything to the power of 0, any number to the power of 0 will give you 1. Okay? Except 0 itself. Except 0 itself. 0 to the power 0 is undefined. Okay, undefined. In some cases, you're also gonna hear this equal to be 1, but we talk about this in higher classes. Okay, so for right now, just understand this undefined. Okay, so it's undefined. Okay, so that was the exponent rule, and this was basically all the rules of exponent. Is there any rule? Okay, I'm sorry, one rule is still left there, which is negative rule of exponents. Okay, negative rule of exponents. Let's write this down here. Negative rule. This is the fifth one. Negative rule of exponents. Negative rule of exponents. And what does this thing mean? Negative rule of exponents means that the exponent is going to be negative. Okay, negative. For example, when you have 2 to the power negative 3, we have dealt with positive numbers, positive real numbers as the exponent. We have dealt with 0 also, but now we're going to deal with negative exponents. How do you deal with negative exponents? Okay, so it's pretty simple. You can arrive at this also from this expression. You can also arrive at this from this thing. Let's say we have 3 to the power this and 6 at the bottom. Okay, so you know that if you subtract these two, okay, so you know that if you solve this with exponent method, we want to get this, we will get this. Okay, so it means that this is equal to this one. Okay, and now we're going to solve this using simple arithmetic so that we can arrive at the answer of this one. So this will be 8 and divide by, this is going to be 64. And if you do this, what you're going to get is 1/8. Okay, 1/8. You're going to get 1/8. It means 2 to the power minus 3 is 1/8. How come? It means 1 divided by 2/3. Okay. The exponent becomes positive when you write 1 at the numerator. Okay, so and this goes in the denominator, then this becomes positive. Okay, so 2 to the power minus 3 is 1 over 2/3. Okay, this is what the negative exponent rule says, and we can write this in variables algebraically, and this will go like this: a to the power, let's say a minus number, minus n, will be 1 over a to the power n. Okay, this is what it will be. And just like this, also a to the power n will be a to the power, I'm sorry, just a to the power n will be 1 over a to the power minus n. And again, if you want to get the proof of this, we can deal with a number having a positive. This time, let's take an example of this one. Okay, so here you can write this as 3 to the power 1 minus a minus number. Let's say minus 1. Okay, this is basically adding 1 to this, which is this one, 3 squared, or the original number. And you, in terms of indices, the rules of exponents or indices, you can write this as 3 to the power 1 divided by 3 to the power minus 1. What you have to do is you have to further simplify this to make this look like this one. Okay, and what you're going to do is write 3 there, and 1 over, you're just going to put 1, and you're going to take the 3 over there, and it will be subtracted. It will be subtracted because this is dividing this one. So you can write this thing as this one, and this will solve to be 1 over 3 to the power minus 2, which is same time. If you compare this with that one, then it is, when you have a power in, when you have exponent in positive, it becomes negative exponent. This will lead you to the same answer, and that's the relationship between this. Okay, it means when you have a to the power n, it is 1 over a to the power minus n, which is this equation right over here. Okay, so that was a negative rule of exponents, and these were the rules of exponent. And I hope you have got this, you have understood this, and you have noted all the things down. Okay, so that was it in this video, and see you in another video.